Okay, we are here once again, and we'll be taking the 2025 chemistry practical. This year it took a lot of time before the practical, slip was circulated. So, but it's here right now. So, and for our A, we are going to be using hydrochloric acid. That's the acid that we use in the titration. And for the base, we are going to be using NaHCO3. That's sodium hydrogen triisocarbonate, or you call it sodium hydrogen bicarbonate. Okay? So then for our C, it's going to be a mixture of copper sulfate, copper 2 sulfate, and glucose. Okay? So it's going to be a very interesting one. Let me start with these first two. Okay, although I won't carry out titration now, but the next video, like tomorrow or next, we are going to look at titration properly. But these two substances, this will be the acid and this will be the base. And as far as this substance has CO3, that's our triisocarbonate, it has the likelihood of giving out CO2 gas. Now, so questions that will come up from this particular setup might contain looking for volume of CO2 gas, might also contain finding X, like let's say we have to find XHCO3, it is something like that. Then we can also get questions that have to do with impurity. Yes, so these are the three angles that they might likely go. So we can try to solve questions that relate to these particular areas of titration, which we will still do. But let us just have a kind of overview of what the practical is about. Now, when these two acid and base react, this will give us something like this. This equation, HCl plus, so I'm supposed to be like, oh, is this not acidic salt? Yes, it's an acid salt, but let me tell you why. It can also act as a base. Before I come to this reaction, when you dissolve this NaHCO3 in water, it's going to undergo what we call hydrolysis. When this splits, it's going to give us Na plus, and this will give us HCO3 minus. Then this water, definitely you know about water, to give us H plus and to give us OH minus. Okay, then OH minus would definitely, go with sodium to give us NaOH, which we all agree that is a strong base. Then H plus will go with HCO3. H plus H will give us H2. So that will give us H2CO3, which is a weak base. So now this one being weak will be totally neutralized, and the strong base would fire down in the reaction. So when we are reacting this is the main substance as acting as a base, while this guy is totally neutralized. I hope this is very, very clear. Okay, then let's look at the reaction that you will use during your examination. Now, you know what? Anytime you add acid to any substance that has CO3, it has a high tendency of giving us CO2 gas. So let's give out our CO2 gas here. When you give out our CO2 gas, we are left with HCl Na. So Na will go with Cl to give us NaCl plus H2O. I hope this is quite clear. Yeah, thank you. So now let's move to the C part. That's what I'll be dwelling on today. Okay, for the C part, it is extremely easy that if you get a salt that contains this, that means you are testing for two things. You are testing for Cu2 plus and you are testing for SO4 2 minus. So this guy is inorganic. So you might hear the word inorganic salt, okay? Like C is a mixture of inorganic salt and organic substance. Like glucose is organic, okay? And you will test for this guy using Ferlin's reagent. Okay, and this guy, let's quickly do test for Cu and test for SO4. Then you see what I'm talking about. So there will be a table like this. Either it is already drawn and you have to fill it, or you have to draw it yourself. Depends on how I want it this year. then your inference. Inference means your conclusion about what you have done. Okay, so like I was saying, our C is a mixture of CuSS copper 2 sulfate. That means we're going to be testing for copper 2 ion, and we're testing for SO42 minus ion. And for glucose, we're testing for CH2, okay, using Fehling reagent. So let's test for some of the ions in that salt. And this is how the mixture of the salt looks like. Okay, you'll be asked to, first of all, add water. Okay, then after adding water, it will dissolve in water. So your inference will be something like this: C plus water. To give you, it dissolves in water. So in case you are asked why does it dissolve, maybe in number 3 question, if all sulfates are soluble except just very few ones, that's except Ba, DaSO4, and CuSO4, which is slightly soluble, and glucose 2 is soluble. So to form a clear slight blue solution when you add it in water, then you now come to your inference, it's a soluble mixture. It is a soluble mixture. Okay, then after that, you might be asked to test copper first using NaOH. So when you add NaOH in drops, they ask you to add in drops. Now, when you're adding in drops, you use dropper. Okay, I'm doing this because I'm already used to reacting this stuff, so I can actually do this without, this is drops. You can see that it's giving me pale blue precipitate. These things are practical, it's not magical. Okay, then you now add in excess. Yeah, after adding in excess, you can see it still remains pale blue precipitate. So when it gives you that pale blue precipitate, it simply means that copper is present. So you come here, you say C plus NaOH. Don't forget, NaOH must be aqueous because it dissolved in water. C plus NaOH in drops. Okay, and excess. Okay, you come here, your observation, what did you observe? Notice that it gave a pale blue precipitate, okay, which is insoluble in excess. Okay, then you come here, you say Cu2 plus is present or suspected. Okay, we are not sure yet. Then we have another mixture, the same solution. They can ask you divide it into 4 portion, 3 portion, then you have another one. Then you'll be asked to add ammonia. Now, you first of all add in drops. In drops, it will give you kind of pale blue also. Then when you now put in excess, it dissolves to form a deep blue solution. So when it gives us this deep blue solution, that means copper has been confirmed. So C plus ammonia, don't forget, ammonia is also aqueous, okay, in drops and excess. Okay, so you must always tell us what happened in excess. If not, you lose marks. Not mark, marks. So pale blue precipitate, okay, in drops, which you observe, and it turned deep blue solution in excess. Then you now say Cu2 plus is confirmed. Okay, so you can see that it's that easy. Then for you to test for sulfates, it's a lot easier to test for sulfate than every other one. So for sulfate, when you add your C plus, then we'll first of all ask us to add barium chloride. If you add barium chloride, we'll give you white precipitate. Okay, we'll take this in our next video because I don't want it to get a lot long and boring. So when you add barium chloride, give us white precipitate, you suspect 4 brothers. Take note, that will be your inference. This is the observation. This is what they will ask you to add. They will now suspect. Now our inference will say SO42 minus, CO32 minus, SO32 minus, and S2 minus. Suspected, or you say present. Then after you confirm that it's this guy, then you now add HCl. When you add HCl, it will still remain white precipitate. Next class I will tell you why it will remain white precipitate. Okay, then you say SO42 minus is confirmed. Okay, I believe that you have been able to have an overview of what will definitely happen. Okay, but before then, for the glucose, when you add Fehling's reagent A and B, A plus B, you mix it together, then this is just for teachers, but students will just call it Fehling's solution. When you add it to glucose, it will give you brick red precipitate when you heat. Brick red precipitate, okay, showing that glucose is present. Then in your inference, you just write glucose present, or you write alkanal present, or you say CHO is present. CHO is the functional group for alkanal and also glucose. Okay, and that's why we call glucose aldose. Thank you very much for listening. See you in our next class. Please don't forget to like, share for other students and teachers to learn, and also subscribe if you are watching from YouTube. Bye.